Today we're going to continue with bearings. And before we get straight into it, let's just talk about what a bearing is. Well, three-figure bearings actually. Just to refresh your memory a little bit, if you have a point A and you have another point B, and I want to know what um on what bearing is B from A. Well, from A means I'm starting at A, so I would put a north line at A and then a line connecting A to B. And this angle, this clockwise angle formed between the north line at A and the line connecting AB will be this here is your bearing of B from E, right? And it was important, some very important things. One is that it's always the clockwise angle. And two, it is the angle formed between the north line at your starting point. So if you have, let's say you have, using A and B again. So let's say this is A and you have B over here. And I want to know what is well, let me just draw in this here. So this is A, B, right? And my north line is at A. Oh gosh, I don't know why I'm not using the actual tools. It's laziness. Sorry, girls. So right, so your north line is at A here. All right, and let's say that this angle here is 62 degrees. Well, that is the bearing of B from A. However, when you're writing it, you would write it as, so we'll say that B is on a bearing of 0.62 degrees from E, right? Because you have to use three figures when describing a bearing. There are two angles around this point E. You have one angle, which would be this anti-clockwise angle here, and that anti-clockwise angle will really be 360 take away 62. Why? Because the angles around a point is add up to 360 degrees. So this angle here is really 298 degrees. However, your bearing is always your clockwise angle. So this angle here is your bearing of B from E. All right. So when Safi had said this interesting thing last week, which was when the angle is when the point is on the left, it's going to be the acute, well, it's going to be the angle on the right. So it'll be this angle. But if the point was here on the right, it's going to be the opposite way. Let me put that in a diagram, which would be easier to understand, right? So let's say we have still using A and B, right? So let's say A is here and B is here instead. And I want to know what is the bearing of B from A. Well, from A means it's starting at A, all right? And you're gonna draw your line connecting AB, all right? There are two angles here between your north line at A and your line connecting AB. You have two angles. You have um this anti-clockwise angle here, right? And then you also have a clockwise angle on this side. Clockwise is this direction, anti-clockwise is the opposite direction, right? So your bearing here is going to be the green angle because that's the clockwise angle between your north line at A and your line connecting AB. So if this angle here is 106 degrees, then the other angle, well, they would both add up to be 360 degrees. So this angle here, which is the bearing of B from A, will be 360 minus 106, which is equal to how much? 154, I think. Yeah, 254, sorry. 254. 4 degrees. So here, the B is on a bearing of, well, there's no need to add any extra digits because 254 is already 3 digits. So B is on a bearing of 254 degrees from E. All right, guys, I hope that rings a bell. Your bearing is, so your bearing, some points about your bearing, it has 3 digits, right? So that it has 3 digits. What else? It is the clockwise angle. It is the clockwise angle. So always the clockwise angle, never the anti-clockwise one. It is the clockwise angle. It is formed between the north line. So it is formed between the north line at the starting point and the line connecting the 2 points, right? So those are some things to know about your bearings. In this one, it's the clockwise angle at A that is formed between your north line at A and the line AB. All right, so let's look at a fundamental, um, you'll remember like a pair of parallel lines and a transversal. So like if you have a pair of parallel lines, let's say this one and this one. First of all, what are parallel lines again, guys? Anybody could tell me what are parallel lines?
Lines that don't meet at any point.
Correct. They are called equidistant lines. So they are lines that never meet, right? So they are usually, you usually identify them with these arrowheads, and the arrowheads could be anywhere on the line, right? So you have parallel lines like this. You could have them in any direction. So um, you can also have two parallel lines, like two vertical parallel lines. It could be two vertical parallel lines. It could be two horizontal parallel lines. It can be like diagonal. Once they are two lines that are equidistant, meaning that they will never touch, then they are parallel lines, right? And this third line that I am drawing here, that third line is what we call a transversal. So it is a line that cuts the pair of parallel lines. All right. So in previous forms, like in previous levels, you would have learned about the angles formed between a pair of parallel lines and the transversal. That would be like the angles formed like here and here. These are called alternate interior angles and they are equal to each other. Also, this angle here, these are called vertically opposite angles, so they'll be equal to each other. All of these red angles here are actually equal to each other, right? This angle here is vertically opposite to this one, and also it's corresponding with this one. So the green ones are corresponding angles on your left side, and then the green ones on the right side are also corresponding angles, right? So you could, if you know what one angle is, around when you have a pair of parallel lines, you could figure out all the other angles. Let me just show you that quickly, right? So like if I had um one moment, let me draw it back. So let's say I had a pair of parallel lines, one, two, right? And then I have a transversal. I'm gonna put a transversal this way instead. Okay. So let's say this angle over here is 70 degrees, right? Well, this 70 degrees will also be equal to this angle over here because they are vertically opposite angles. All right. On top of that, that 70 degrees and this angle here will also be equal. They are called alternate interior angles. And then, of course, here will be 70 degrees as well because it's vertically opposite, right? Now, if you look at any directions, like if you look at this direction over here, right? These two angles are on a straight line. So therefore, they would add up to be 180 degrees. And that means that this one will be 110, right? Because they're on a straight line. They're on a straight line here, and they're also on a straight line in this direction. So this angle here will also be 110 degrees. And then here will be 110 degrees, and here will also be 110 degrees. So that's just something to refresh your memory a little bit about the angles formed between a transversal and a pair of parallel lines. So if you notice, girls, these two interior angles, this one over here and this one, oops, sorry, here, they also add up to 180 degrees, right? 110 plus 70. These two will add up to be, these two will add up to be 180 degrees. All right, so those interior angles on the same side of the transversal adds up to be 180 degrees. So like in this diagram here on the right, all right, if I know that this angle over here, let's say this angle is 120 degrees, then I can figure out what this one here is because they both add up to 180. So this angle here would actually be 60 degrees. All right, so the angles formed between the parallel sides, well, between the parallel lines on the same side of the transversal. So it's between the parallel lines, right? So it's between these two. All right, on the same side of the transversal, what we call supplementary angles because they add up to 180 degrees. Okay, so we're going to use that same principle with bearings. It's something that students they forget about all everything that they've learned before. That's a problem I think that students have with math. They do not make connections. Nothing in math is isolated. It's all linked. So everything that you learned about angles, angles around a point, acute angles, obtuse angles, everything that you've learned about angles ever will apply in anything you have to do with angles, right? So you don't just like forget about all the things that you know about angles that you learned in Form 1 and not expect to use it in Form 4, or even the things that you learned about angles in primary school. It still is important because those are just fundamental truths. They are facts, okay? So the angles formed between the parallel lines on the same side of the transversal are supplementary, meaning that they add up to 180 degrees. And in bearings, we actually use that principle. So I'm just going to write this down. You could copy it down as well. It is important. It's a good example, right? So let's say the bearing of B from A is 126 degrees. What is the bearing? What is the bearing of A from B then? All right, so let's draw a diagram. The bearing of B from A. So if it's from A, it means our starting point is at A, right? So let's do our diagram. Say here is A. And if it's like 126, that might be like over here. So let's say this is B. So my bearing of B from A, well, you have your line connecting AB, and your north line goes at A because it is the starting point, right? It's the bearing of B from A. So whatever it's from is where you put your north line. So this bearing over here, this is my north line, 126 degrees. This is where it will be. All right, because the bearing of B from A is that clockwise angle between the north line at A and that line AB. So this is my bearing, right? Now, if I want to find out what is the bearing of A from B instead, well, if it's from B, I need to put a north line at B. So my north line will go here at B. And there are two angles here. This first angle over here, which is actually the anti-clockwise angle because that's opening from north, it's opening this way. So that would be the anti-clockwise angle. And the bearing, however, is going to be the clockwise angle formed on the outside here. So this would be the bearing of A from B. Now, I can figure out what the angle inside that anti-clockwise angle is because, girls, these two north lines are parallel to one another. And since they are parallel to one another, it means that the two angles between them add up to 180 degrees, like this, right? Like this. So if this angle is 126, then this angle here will be 180 minus 126, which is equal to 54 degrees. And since here is 54, I can find the angle on the outside because they're both angles around a point. So the bearing of A from B would simply be 360 minus 54, which gives me 306 degrees. So the bearing of, you'll copy this down, huh? The bearing of A from B is therefore 306 degrees, right? So to do this again, if you know that the bearing of B from A is 126 degrees, and you want to find what is the bearing of A from B, well, you first draw your diagram so that you label it and you see where the bearing is and that kind of thing. And then if you're looking at the bearing of A from B, it means the starting point would now be at B, which means you need to put a north line at B. And there will be two angles around the point B. You'd have the inside angle there, which is actually an anti-clockwise angle. And then you would have your clockwise angle on the outside, your reflex angle there. And the bearing of A from B is going to be that clockwise angle. So you use the principle that the two angles formed between the north lines will be supplementary, meaning they add up to 180 degrees. So you can find out what the inside angle is by minusing 180 minus 126. And once you find what that angle is, you can find the bearing because there are two angles around a point. So you just do 360 minus 54. That would give you your answer. So I'm gonna do one more like this with you guys, and then I'm gonna give you all some to do with me, well, for me, and I want to see you have to draw your diagrams. Try to use a ruler, please. And it's you don't need to use your protractor, but at least make it kind of believable, right? So like if it's a obtuse angle, you want to make sure this is more than 90 degrees. If it's an acute angle, it should look less than a right angle. Okay, so let's do another example. Um, let's say the bearing of the bearing of P from Q is 060. What is the bearing of Q from P? Okay, so first thing, you need to draw your diagram. All right, so drawing my diagram. Well, firstly, P from the bearing of P from Q. Okay, so that means your starting point is Q. I just like to put it over here. I put my first point here, but you don't need to do it like that. So from Q means my north line goes at Q. And then if the bearing of P from Q is 60, well, that means I need to draw my point my point P has to be like here, because this angle formed between the north line at Q and the line QP would have to be 60 degrees. So it has to be up here. So this here is 60 degrees. All right. So if I want to find out what is the bearing of instead Q from P, so if it's from P, I need to put a north line at P. So a new north line is going to go here, right? So that would be my north line. And the bearing is going to be on the outside here because that's the clockwise angle. That would be the bearing of Q from P. So using my rule that the angles between the north lines and this line QP will add up to 180, means that this angle here will be 120 degrees, since this is 180 minus 60. Right? 60 plus 120 gives me 180. So that's how I got this angle. And now to get P, the bearing of Q from P will be 360 take away 120. So that gives me 240. So the bearing of Q from P will be 240 degrees. Bearing of Q from P is 240 degrees. Okay, guys, so I want you all to try some for me. I'm going to write them here on the screen, and then you're going to try it. Just copy down the examples so that you have something to follow. The bearing of C from D is 292 degrees. What is the bearing of D from C? Then the bearing of Y from X is 162 degrees. What is the bearing of X from Y? Then the bearing of A from B is 212. What is the bearing of B from E? And then finally, the bearing of Z from Y is 125 degrees. Well, I don't have the degree sign, so please you put it in. I'll write this in also. What is the bearing of Y from Z? So I want you all to try these for me, please. Let me know if you were getting it. The first one said the bearing of C from D is 292 degrees. So that means if, let's see, if it's from D, it means the north line has to be at D. So I would say that because it's 292 degrees, it has to be an anti-clockwise. Sorry, C would have to be on the left of D, right? Because if C was on the right of D, it would be a much smaller angle. It would be like an obtuse angle. It wouldn't be a reflex angle, right? So C would have to be here. and D would have to be here. All right. So if it's a bearing of 292 degrees from D means that your north line goes at D. All right. And then your line connecting C to D, that would be your line there. So then the angle, that bearing of 292 degrees is going to be this angle on the outside here. So this angle is 292 degrees. Here we have C on a bearing of 292 degrees from D. So if I want to find out what is the bearing of D from C then, well, I'll put my north line at C now because it's from C. So I put my north line here. So now the two north lines are parallel to one another. Okay. And I can figure out the angle because, well, if this angle on the outside here is 292, I can figure out what this angle here is. This angle will be 360 take away 292, which is 68 degrees. And now I could find out the bearing of D from C because that's going to be this clockwise angle over here. And that angle and 68 will add up to be 180. So 180 take away 68 is 112 degrees. So this angle here is 112 degrees. All right. The next one is, so this is question one. This is question one. Question two, I'm going to put it up here. It said the bearing of y from x is 162 degrees. What is the bearing of x from y? So the bearing of y from x. So that means x could be here. And if x is there, it's from x, okay? So your north line will go at x. That's your north line there. And then an angle of 162 degrees might take you, well, remember your angle of 180 is a straight line. So 162 might be like around here. So that is your angle. This here would be your point Y. So Y is on a bearing of 162 degrees from X. So that's this angle over here, right? That is the bearing Y from X. So if I want to find out what is the bearing of X from Y, well, I need to put my north line at Y because now I'm looking at the other direction, right? So my north line goes at Y, and that would be the bearing of X from Y will be this angle on the outside here. That's the bearing of X from Y. So I'd first need to find out what the angle on the inside is, and that angle will be 180 take away 162, which gives me 18 degrees. So this angle here is 18 degrees. And then 18 degrees plus the angle on the outside is adds up to 360 degrees. So 360 take away 18 is 342. So the bearing of X from Y is 342 degrees. Okay. Number 3 was the bearing of A from B is 212 degrees. So A from B is 212 degrees. So then let's put A to the left of B then. So if this is A, let's put B over here. And I'll explain this again as well. So if the bearing of A from B is 212 degrees from B, means your north line goes at B. Your first north line goes at B. All right. your line connecting AB. So the bearing of A from B would be this angle on the outside here, which is 212. Okay, so that's 212 degrees. So then your bearing of, actually, guys, I want to draw over that diagram. The reason is, so y'all, for this topic, you need to have a good sense of your angles, right? So before we do that question, let's look at let's look at some angles, just some general things. So if you have, let's say you have a quadrant like this, right? This is a quadrant and it's made up of four right angles. So this angle here is 90 degrees. This angle here is 90 degrees. Here is also 90 degrees. And this is also 90 degrees, right? Those are all the angles around your point. It adds up to 360 degrees, all right? So any angle on this side from here to here, so over here, any angle between there will be between 0 and 180 degrees, right? So any angle that is so greater than 0 or less than 180 will fall anywhere here. So you could have, for example, if you have an angle like this, well, that might be 45 degrees, right? And then if you have an angle from here to here, from here to here, then that's going to be more than 90 degrees, but less than 180. So that might be like a 120-degree angle, right? So any angle that is between 0 to 180 degrees will be on this side, okay? So you can think of it in terms of when you're drawing your diagrams, if the bearing of, let's say, D from C, right, is 112, you would expect D to be to the right of C, right? Now, any angle that is more than 180 degrees but less than 360 will be to the on this side here, right? From here to here, so you're looking at the whole thing, any angle formed. So on this side, you'll end up with angles that are more than 180 degrees, but less than 360, okay? At this point here, an angle, let's say you had an angle from around here stopping up to here, well, that would be an angle of 270 degrees because that's made up of 90 plus 90 plus 90. So that would be 270 degrees. So if then I want to draw an angle that's 212 degrees, it can't be up here because then that would be more than 270, which is over here, right? So if I'm looking at an angle that's 212, well, it would be more than 180, but less than 270. So it might be like around here. Okay, guys? So you have to, even though you're not using a protractor, you have to make sense of your angles. So that's why I said I'll draw over the one just now because I had it up here, but that wouldn't make sense because if I put an angle up here that starts at this point, then that's going to be more than 270. And I wanted to draw an angle that was 212 degrees. So an angle that's 212 degrees might be maybe down here. A would be here, and let's say B is up here. This makes more sense. Let me show you why. Well, if it's the angle, if the bearing of A from B, so this is your line AB, your north line will go at B because that's where you're starting from. That's your starting point. So this is your north line here at B. Right? So this makes more sense because now this angle on the outside here, this angle here is more like 212 degrees, right? Because this angle would have passed here, which is 90, past here, which would be 180, but is less than 270. So 212 might be there. Okay. So that's my angle of 212 degrees. And now the bearing of B from A then, well, I'll draw my north line at A now since I'm looking at the bearing of B from A. So this would be my north line here. And the bearing of B from A will be this clockwise angle over here. That is your bearing of B from A. So to figure out what that angle is, well, I would first check what the inside angle is here, this angle over here. And I could work that out because these two angles, the angle of 212 and that one, adds up to be 360. So 360 take away 212 is 148 degrees. All right. And then that angle of 148 degrees plus the bearing would be 180 degrees. So 180 take away 148 is 32 degrees. So that means my bearing of B from A, which is here, will be 32 degrees. So I know this part is a little tricky, and the reason it is a little tricky is because you're not using a protractor, and it's also just a little bit of recalling everything that you know about angles, right? So bear with yourself, be patient with yourself if you're having a little trouble with it, okay? Just make sure you understand the fundamental things about the bearings. It's the clockwise angle between the north line as your starting point and your line connecting your 2 points. The next question, question 4, was that the bearing of Z from Y is 125 degrees. So again, remember thinking about your points, right? Up here, if your line starts here, that's 0, then here would give you 90 degrees. And then here would be 180 degrees, right? And let me use dotted lines. Yeah, so here would be 180 degrees. From here to here is 90 degrees. And then on this side, you would have 270 degrees, right? So if I'm looking at an angle of 125 degrees, well, starting here, it would be probably it might come like somewhere around here. This angle here is an angle of 125 degrees, right? So then now I have an idea of what my angle should look like. So the bearing of Z from Y is 125. So that means that if Z is my starting point, oh no, sorry, it's yeah, Z from Y. So then it means Y is my starting point. So Y would be here and Z will be here, right? So notice it looks like the diagram that I just sketched here, right? Look, see? So this is my north line. So the bearing of Z from Y is this angle over here, which is probably approximately 125 degrees, right? That's this angle over here. So now to figure out what the bearing of Y from Z is, well, Y from Z means I need to put my north line at Z. So my north line goes there at Z. Let's label it north. Oops. Right? So the bearing of Y from Z is going to be the clockwise angle. So the bigger angle on the outside here is my bearing of Y from Z. So I can find out what the interior angle here is because this angle over here, right, would be 180 take away 125, which is 55 degrees. And now I could figure out the bearing because the bearing will be 360 take away 55. So 360 take away 55 is 305 degrees. Okay? And that's your answer. I want to do another one. This was number 4. So I'm going to do another one. Let's say the bearing of D from C is 352 degrees. What is the bearing of D from C from D? What is the bearing of C? No, D from, no, sorry, yeah. D from C, so C from D, so the opposite. Okay, so let's go. So an angle of 352 degrees, guys, will be, let's do a little sketch. If your north line is here, right? And so this will be your point D. This will be your point D here, okay? Because we're looking at, oh no, sorry, it's D from C. So C is where your north line would be. If you're looking at the bearing of D from C, well, that angle is going to open. So it wouldn't be up to here because that would be 90 degrees. Up to here will take me to 180 degrees. Here will take me to 270 degrees. So 352 will be much closer to the north line because 352 is actually almost 360 degrees, right? So that angle is gonna be a big angle all the way around here and then like maybe there. So that is your line. That's where your line connecting C to D would be. That's where it would be. So this point here is D. This is your point D. All right. So then to get your bearing of C from D now, sorry, D from C. What am I? I'm mixing it up all the time. Sorry, guys. C, this should have been the bearing of D from C. So now what is the bearing of C from D? Good. So this is your point D. Let's put our north line there. All right. So this is your north line. The bearing of C from D will be this clockwise angle right here. All right. So this angle on the outside here was your angle of 352 degrees. So then this angle here is 8 degrees because 352 plus 8 will give you the 360. And then this angle here will be 180 take away 8, which is 100 and 180 take away 8. 180 take away 8 is 172. And that's your answer. Right, guys? So anybody got these? Were you all able to get these or they were very confusing?
Miss, I didn't even reach there.
Where you reach?
I was on 2.
Oh, you want to? Okay. Well, were you able to follow with me?
Yes.
Okay, good. What about the rest of you? Were you all able to follow with me? Should I do some more like this? Or you all think you get the hang of it? Talk to me, ladies.
Yes. The only
Okay.
problem for me is the wording of the problems.
You
That's the
wouldn't.
yeah.
Okay. So I think one of the things that I like try to, one of the cues that I use is whenever I see that word from, so like from C means the starting point is at C, which means the north line has to go at C. right? So that's one of the things that helps me with it, honestly. You guys want to take a short break? And then we'll come back and do some questions. Girls?
Yeah. Yeah.
All right.
Yes.
So let's take a short break. Let's start back at 5:30. Gordon. So it says on the diagram, insert the bearings 0, 4, 2, so 42 degrees and 130 degrees. That's the first part of the question. That is worth 1 mark, right? So it says the ship is from point A to point B. So this is your point B up here. Put it on this side. This is B over here. And then this must be C, right? Your north line, and it was actually labeled there, I forgot to write it in. Your north line is here. So if the ship, it says that point B is 15 kilometers away from E. So that means here is 15 km, right? And also that B is on a bearing of 42 degrees. So the bearing of B from E will be this angle over here, this angle here, which is 42 degrees, right? And then it says the ship then sails to point C. So it's leaving B and sailing to point C, which is 19 km away from B. So this distance here is 19 kilometers and is on a bearing of 130 degrees from B. So this will be your north line here. So then the bearing of C from B will be this angle over here, which is 130 degrees. That is the first part of the question, which is worth 1 mark. The second part of the question, which is worth, let's see how many marks. 2 marks. It says to calculate the distance between town A and town C. Okay, so to calculate the distance between town A and town C. So I need to find this distance here. All right, what do I have? Let's see. Well, guys, I can figure out, I'm gonna have to use one of the rules, right? Whether sine or cosine rule to find an unknown side in this triangle. But before I could use one of those rules, I need at least one angle, right? So the angle that I can figure out here, though, is I can figure out what angle B is equal to. And the reason I can figure out what angle B is equal to, I don't know if you all realize this as yet, but these two north lines at A and B are parallel lines. So that means this angle here, this angle on the outside here, plus 42 makes up 180 degrees, right? So I could find out this angle by saying 180 take away 42, and that gives me 138 degrees. And then, of course, those 3 angles are around a point. So this angle on the inside here, I can figure out what that is because the 3 angles, 138, 130, and that angle B will add up to give me, it'll add up to give me 360 degrees. So I can work it out by saying 360 take away 138, take away 130, which is 92 degrees. So this angle on the inside here is 92 degrees. And now I can find the distance AC by using the cosine rule. So we will recall the cosine rule, right? So using cosine rule, using cos rule. This is given to you in your list of formulae, by the way. AC squared, that's the side I'm trying to find, is equal to sum of the squares of the other two sides. So 15 squared plus 19 squared minus 2 times the product of those other two sides. So minus 2 times 15 by 19 by cos of that included angle, which is 92 degrees. So then this would give me AC squared is equal to, so we could work this out. You could type that whole thing in on your calculator, 15 squared plus 19 squared minus 2 by 15 by 19 by cos of 92 gives me a very big number, 605.8927. I'm just going to write the 4 decimal places. And therefore, if AC squared is equal to that, then AC will be equal to the square root of that. So square root of 605.8927. I'm going to put dot, dot, dot here because I didn't remove it from my calculator. And now I'm just going to press square root and press equal. So therefore, AC is equal to 24.6 p.m. And this is taken to 1 decimal place. So that's 2 marks, guys. So far it's 3 marks. 1 mark for labeling your bearings 42 and 130, and then 2 marks for finding the distance of AC, which is 24.6 km. And then the third part of the question asks us to determine the bearing of A from C. So to determine the bearing of A from C, all right? So A from C, this is A from C means that we're going to be looking at the north line at C here. So I'm gonna actually draw over the diagram just so that we have more space, right? So just bear with me a little while. Let me draw over the diagram. So the diagram looks something like you have A here and E, and then you have C over here, AC is here. All right, so this is, oh, and let me put in my north line. So you have a north line at A, you have a north line at E, north line at C. Okay, so these are, this is A, this is C, this is B. Here is your north line at A, this is your north line at B, and this is your north line at C. And we had figured out some of the angles there already. Angles were, well, this angle here was 42 degrees. This angle over here was 108. And the one on this side was 130. So those were the angles I had. Also had this angle on the inside here, which was 92. All right, so I need to figure out, the question is asking me to to determine the bearing of town E from town C. So if it's from town C, it means I'm looking at my north line at C and my angle formed between AC and that north line, my clockwise angle. So the angle, the bearing of A from C is going to be this angle on the outside here. That is the bearing of A from C. Okay. All right. So let's see. Well, if this angle up here is 138, then I can find out what this angle here is, because again, there are 2 parallel lines. So the 2 north lines at B and C are parallel. So this angle here will be 180 take away 138, which is 42 degrees. So here is also 42 degrees. All right. Now, in order to find out what the bearing is, that outer angle, I would need to know what this inner angle here is. And the reason I need to know what that angle is is because the three of them will add up to 360. So I can find out what this angle is by using one of the rules that I have. Now, in the question, they also gave us the lengths, right? We had AB is 15 and BC is 19. So here was 15 km, here's 19 km. So I can use one of the rules to figure out what this angle is here. Either sine or cosine. And then we just worked out the bottom, which was 24.6 km. This angle here is 24, sorry, this side here is 24.6. So I can use any one of the rules to figure out this angle. So I am going to use the sine rule to figure out the angle at C, right? Recall that. So using your sine rule, C over sine C is equal to B over sine B. In this case, C is the side opposite angle C, which is 15. So 15 over sine C, which is what I'm trying to find, is equal to B, which is 24.6 over the sine of B, so sine of 92. And then you cross multiply, so this would be 24.6 sine C is equal to 15 by sine of 92. And therefore, sine C is equal to 15 by sine of 92 divided by 24.6. And so angle C will be equal to the sine inverse of that. Sine inverse of 15 sine 92 divided by 24.6. All right, so on your calculators, you'll do 15 sine 92 divided by 24.6. Then you find sine inverse of that, which will give you C as 37.5 degrees taken to 1 decimal place. So now this angle on the inside here is 37.5 degrees. So now that you have the angle 37.5 and the angle 42, you can find out the bearing of A from C. You could find out this angle on the outside because all of them will add up to 360. So all I do is I say 300, and so this here, which is what we're trying to find, will be 360 minus the sum of 37.5 and 42. That gives me, let's see, 360 take away 37.5 plus 42 is 280 degrees, 280.5 degrees. So therefore, the bearing of A from C is 280.5 degrees. So this is how we will bring everything that we learned so far from the sine rule, cosine rule, and bearings into solve a question. So next week, well, not next week, the following week, because we're not having class next week. We're going to tie everything in together. So what I want you to do next week, if you have time, or like whenever you have time between now and our other class, is to revise the sine and cosine rule, because we're going to use it in solving CXC questions involving trigonometry, which has bearings as well, right? So this question was taken from me 2025, question 9A, and it was worth 6 marks. The first mark was for labeling the bearings. The second mark was to find the distance. The other 2 marks, sorry, was to find the distance AC, and then the third part of the question, which was with 3 marks, was to find the bearing of A from C.